All right, so we see that the sine of 110, sine of 70 matches. Let's take a look at what happens with the cosine. Take the cosine of 70, x over r. What do we get?
0.342.
Now take the cosine of 110. Negative 0.34, blah, blah, blah. Notice, x is negative, isn't it? Y is positive. And if you write this in your notes, r is always positive. Write this in your notes, r is always positive, because all r is a distance from the origin. So r is always going to be positive. But because x is negative, x over r gives you a negative value. So we're going to have to account for that. Because if you take the cosine of 70, the reference angle, you don't get that negative, do you? You'd have to consciously think, wait, because of the negative here, I would have to put that negative on to actually make it equal to that. So in the second quadrant, we're going to have to stick a negative on. Think about this. What about the tangent of rho? Y over x. Well, y over x, is that going to be positive or negative?
Negative.
It should come out negative. Take the tangent of 70. Obviously, it's going to come out positive.
2.74.
Take the tangent of 110 now.
Negative 2.7.
Right, it's the same value, but with a negative. So again, tangent here, because of the negative x, we're going to have to think to put a negative on. Okay, we'll come back to that thought. Consider the third quadrant. Let's say we have a reflex angle. I don't know, something like this. Well, somehow I got to make a triangle, right? We always draw the reference triangle to the x-axis. So if I draw a line here, here's my y, notice that's negative. Here's my x, notice that's negative. Here's my r is always positive. And notice that the reference angle is going to be this little piece in here, rho. Theta is the entire reflex angle, rho is just that little piece. Well, let's come up with some reflex angle.
250.
250? All right, so let's suppose theta is 250 degrees. How would I figure out how big rho is, the reference angle?
20 degrees. Minus 270.
No. Here's 250. But rho is this piece right here. It's how far past 180
180
did
minus
you go?
250 minus 180.
Right, which would be what?
70.
Hey, guess what? Rho 70 again, right? So it's going to be the same numbers we got a moment ago as far as rho is concerned. But so in quadrant 3, write this down. Rho equals the angle minus 180. In quadrant 3, theta minus 180 gives you that reference angle. Subtract the 180. Now notice, x is negative, y is negative. Think about what it's going to do to the sine. Sine is y over r, but y is negative, r is positive.
Should be negative.
Sine's going to come out negative, isn't it? Take the sine of 250. Sure enough, you're getting a negative value. And it should look somewhat familiar because we just did that same value a minute ago. What about the cosine? That's x over r, right? X is negative. So take the cosine.
Negative.
Negative. In fact, it's the same exact thing we got in quadrant 2, isn't it? Because same reference angle. What about tangent? Well, tangent's y over x, but they're both negative. Take the tangent of 250. It should come out positive.
2.74.
Let's consider for a moment quadrant 4. This is where having both chalkboards available would be nice. All right, let's consider a quadrant 4 angle. Well, same thing. We're going to draw to the x-axis. Here's my x, it's positive. Here's my y, it's negative. Here's my r, always positive. Here's the reference angle. Notice that between theta and the reference angle, together they complete a full 360. So come up with a reference, let's just say it's 70 degrees again for sake of consistency, I guess. How big would theta have to be? 290. Because rho is going to be 360 degrees minus theta. So if theta is 290, hence the rho would be 70 degrees, right? Well, let's think about the cosine, or the sine first of all. Sine is y over r. Sine should come out negative. Take the sine of 290.
Negative 0.9.
Yeah, negative again, right? Take the cosine of 290.
Positive 342.
Positive, right? X over r. Take the tangent of 290.
Negative.
Negative y over x. Do you see that? So we can kind of deduce this about our different reference angles with these reference triangles. In the first quadrant, everything's positive. All functions are positive. In the second quadrant, it was sine that was positive, y over r, because y is positive. And of course the reciprocal, if you flip it, so cosecant would also be positive, right? In quadrant 3 was tangent, because both x and y are negative, and y over x is your tangent. And of course cotangent, when you flip it, would be positive as well, but everything else negative. And then in the fourth quadrant, it's only cosine, because of the positive x value that is positive. Everything else negative. Of course, secant, the reciprocal, would be positive. And of course, here we have our reference angles, 4 letters, A, S, T, C. All sine, tangent, cosine. We need to memorize that pattern. Easy way to remember is just remember that all students take calculus. That'll help you remember the order. All students, once you finish my class, there's no reason you shouldn't go straight into calculus in college, but all students take calculus. This is brainwashing, okay? And remember, all students take calculus to help you remember A, S, T, C. Quadrant 1, everything's positive, all positive. Quadrant 2, sine's positive. Quadrant 3, tangent's positive. Quadrant 4, cosine's positive. And that'll allow us to keep track of these different angles. But again, in each case, you can't really put a 290-degree angle into a triangle, or a 250-degree angle into a triangle, or a 110-degree angle. So we have to use what class? A reference angle, represented by the Greek letter rho. Turn to page 54, if you would, in your textbooks. Page 54 in your textbooks. Look at problem number 3. They give us a point 7, -4. On your paper, go and draw a quick sketch of what this would look like. Plot the point 7, -4 on your paper. 7, -4. And what quadrant does that fall into? Fourth quadrant. Now, I know that the x is going to be what value? 7. I know that the y is going to be what value? -4. And then I need to figure out how big r would be. Well, how do I find r?
So right triangle, do Pythagorean here.
Pythagorean theorem. 7 squared?
28. 49.
4 squared? Well, -4 squared technically.
16.
Still 16 though, right? 16 and 49, 65. And since you can't take the square root of 65 evenly, we'll just leave the square root of 65 for my r. Always positive. Now, the actual theta is here, right? But the rho, the reference angle, is right here. And so as we find the sine, cosine, and tangent of theta, we're not going to look at theta, class. We're going to look at rho, because theta doesn't fit in the triangle. So we're going to look at rho, and our answers are what we're going to say are for theta. So for the sine of theta, sine's what over what? Opposite over hypotenuse, or we could say y over r. We're remembering that y is negative. ASTC, quadrant 4, sine should come out negative here, right? And we would get -4 over square root of 65, or rationalized, -4 square root of 65 over 65, right? For the cosine, cosine's what over what? Adjacent over hypotenuse, or in this case, x over r gives us what?
7 over square root of 65.
Which becomes
7 square root of 65 over 65.
Tangent's what over what, class?
Opposite over.
Or in this case, y over x.
So -4 over 7.
-4 over 7. What about the cotangent of theta? -7 over 4. What about the secant of theta? Stay with me. Square root of 65 over 7. What about the cosecant of theta? Negative square root of 65 over 4. And notice in the fourth quadrant, everything's negative except cosecant, or secant and cosine. Because ASTC, it's cosine's special quadrant to be positive. We did not get nearly as far as I would have liked thanks to picture day, but we will pick up more there in our next lesson. I'm going to have you tackle some homework here. That said, we did not get as far as I wanted to get, so we'll see how this goes. Let's do page 54, numbers 2, 4, 6, 7. 2, 4, 6, and 7 on page 54. And we'll pick up more tomorrow. So again, watching on YouTube, I guess enjoy the short lesson. We got stuck down at pictures for a little while and lost a little time. All right, have a wonderful rest of your day, and you are dismissed. And here's the screen, by the way, where you couldn't see because I forgot to drag the camera back over, video students.